Hey guys, in this video we would understand the transformations of logarithmic functions. We all know that our general transformation equation looks like y is equal to a function of k x minus t plus c. If we have a logarithmic function, then this equation would become y is equal to a. In place of function, we would put log. Whatever is the base, we can put the base. K x minus d plus c. So this is called the general transformed equation of a logarithmic function. The meanings of a, k, d, and c, they always stay the same. A means vertical stretch or vertical compression by a factor of a. K means horizontal stretch or horizontal compression by a factor of 1 over k. D means horizontal translation. C means vertical translation. It is assumed that you already know the meanings of A, K, D, and C. If anybody has any problems understanding the basics of transformations, I would recommend them watching the transformations lesson from Introduction of Functions playlist in the channel. Let's take up the first example. If the equation is y is equal to -3 log to the base of 2, and we're given x minus 1, and we're given x minus 1 plus 2. If the question wants us to describe the transformations, all we have to do is just bring out a, k, d, and c and then explain their meanings. So a we have here is -3. It is a vertical stretch as the a value is greater than 1. So it's a vertical stretch by a factor of 3. It has another meaning because there is a negative sign. So a negative a means there is a reflection over x-axis. Now when we say these transformations are seen, on what base or on what parent function do we see these transformations? We see the parent function is nothing here but y equal to log to the base of 2x. Because base, x, and log, these would belong to the parent function equation. A, k, d, and c is something that is introduced as a transformation. So that was the meaning of a. Next we'll explain what is k. K value is 2. 2 means k is greater than 1, so it's a horizontal compression by a factor of 1 over 2. Next we have d is 1. D is 1 means a horizontal translation by 1 unit right. C is a 2, that means it's a vertical translation by 2 units up. Or we can say vertical translation of 2 units up. Horizontal translation of 1 unit right. Horizontal compression by a factor of 1 over 2 because k is 2, and a vertical stretch by a factor of 3 because a is 3. Since a also has a negative sign, that means there is a reflection over x-axis as well. And we know the parent function is y equal to log to the base of 2x. This is how we write down the transformations when we are given a transformed equation in logarithmic functions. Let's take up another problem. In this, we are given the information of a transformed function. We have to use this information to write down the equation and draw the graph of the function. Let's read the question first. They say if a parent function y is equal to log x, we see here base is missing. Remember, whenever there is no base, it is by default base 10. So y is equal to log to the base 10. X is reflected in y-axis, horizontally compressed by a factor of 2 over 3, vertically translated 2 units down, and horizontally translated 1 unit left. So we would put all this information down as a, k, d, and c to make sure that we are able to put it back into the transformed equation. Now, parent function is reflected in y-axis. Reflection in y-axis means k is negative. Horizontally compressed, horizontal compression or horizontal stretch is also a change in a k value. So if it's horizontally compressed by a factor of 2 over 3, that means k value is 3 over 2. Whenever we change the value from number to words, this is written in words, we know we flip the k. So now whenever we put it back from words to numbers, we again flip it back. So 2 over 3 flipped back to becomes 3 over. So 2 over 3 will flip back to become 3 over 2. Next we have is a vertically translated 2 units down. Vertical translation means c value. 2 units down means it's -2. Next we have is horizontally translated as d value. 1 unit left means -1. What is its equation? Also draw the graph of the transformed function. So let's first write on the equation. Our parent function was y y equal to log x. If you do not put a 10, that would also be okay. If you want to put a 10, that would also be fine. But no base means base is automatically 10. We know the transformed equation is a log k x minus t plus c. Now we just have to fill in the blanks. A is not there, so not there means it's 1. K is negative 3 over 2, so we'll put negative 3 over 2 here. X minus d, so it's minus 1. In place of d, we put minus 1. Plus c is a minus 2. 1 you do not have to show, or you want to show, it's up to you. So it gives you log negative 3 over 2 x plus 1 minus 2. And that's the equation that we would get from the question. So what is its equation? We have got the equation, this part is done. Also draw the graph of the transformed function. Whenever we make graphs of transformed functions, we always use mapping formula, and the mapping formula uses the x values of the x and y values of the parent function. Parent function in this case is y equal to log x. So we would first make the table of values for the parent function. Because base is not there, base is 10, so we would write on the x value as 1 over 10, 1, 10. Y value will be negative 1, 0, and 1. Parent function equation is this. Transformed equation is what we got in here. So we would write on y equal to log negative 3 over 2, x plus 1 minus 2. This is the equation. We would make table of values using the mapping formula, and we all know mapping formula is x over k plus t, ay plus c. If you need to refresh your memory over the mapping formula, I would recommend you watching the transformations video in Introduction to Functions playlist in the channel. So here we know x is what we would get from the parent function. K, we can just mention here the number so that we don't have to keep looking back and forth. K is negative 3 over 2. D is minus 1, so we would do minus 1 here. Here also A is not there, so that's a 1. We do not have to worry about putting it. We would just straight away put y plus c. Plus c is nothing but minus 2. So this would give us the new y. You can write it as y new. And this would give us the new x. Let's write down x new as the green one and y new as the green one. So original x we have from the parent function is 1 over 10. We need to divide it by negative 3 over 2 and subtract 1. We would get the new x for this first point. You can put this all on the calculator. So what you have to do is just 1 over 10 is 0.1 divided by negative 1.5. So we would get 0.1 divided by negative 1.5 minus 1, and that would give us negative 1.7. Similarly, we solve for the y value here. The original y is negative 1. This one is easy because not many numbers to work with. So negative 1 minus 2 gives you a negative 3. So this point became this. Next, we would be working on the next x value, that is 1. Divided by k is negative 3 over 2 minus 1. So this gives us 1 divided by negative 1.5 minus 1. And that would be equal to negative 1.7. Here it was negative 1.07. Next is the y value. Y value parent is 0. So we would do 0 minus 2. That is equal to a negative 2. So this parent point turned into this transformed point. Next we're going to change 10 and 1. And we get 10 divided by negative 1.5 minus 1. And that gives us a negative 7.7. Similarly, the y value would be 1 minus 2. And that would give us a negative 1. So the new points that we would be working on is negative 1.07 minus 3. Next we would have is negative 1.7 minus 2. And next we have is negative 7.7 minus 1. We know in a logarithmic function we would see a vertical asymptote. And the vertical asymptote is x equal to d value. That's the vertical asymptote. We would use this and we would use these points to turn it into a graph. So first let's make the axes, use the vertical asymptote in the points, and we would get the final graph. So we can write it down here that the vertical asymptote we would have is x equal to negative 1 as the d value is negative 1. Let's say here we have is negative 1. We can make the vertical asymptote at negative 1. Then we can plot these points. Negative 1.07 would be close to here. So let's say -7 is somewhat here. This is -3, -2, -1. So we need y values to be negative. -1, -2, -3. So here we have is x equal to -1.07, which is somewhat here. Y is -3. We can make the point here. Next is when x is 1.7. We'll go further down there. Y is -2. Let's say it's here. Next is when x is -7.7, y is -1. So what we notice is that the graph is going to go like this. And this is how the logarithmic transform function equation graph is going to look like.